Hi, my name is Ainsley Adams, and today I will demonstrate how to use SPSS to determine if providing a single 15-minute individual coaching session with an expert bowler significantly improves students' bowling scores. My hypothesis is that a single 15-minute individual coaching session with an expert does significantly improve students' bowling scores. And my null hypothesis is that a single 15-minute individual coaching session with an expert does not significantly improve students' bowling scores. To determine this, I will open the coaching instructions dataset in SPSS. First, I must verify that the conditions to run a paired samples t-test have been met. To do this, I must create a new variable so I can check for normal distribution. I go to transform, compute variable. I'm going to call this diff for difference. And I'm going to do game 1 minus game 2. Oops. Game 2 over ether type. Okay. Now that I have my new variable, I'm going to check for normal distribution. Go to Analyze, Descriptive Statistics, Frequencies. I'm going to select a variable and histograms, show normal curve on histogram, and click Continue. Okay. Now I can see at first glance that the distribution is approximately bell-shaped, but I do want to confirm normality before proceeding, so I'm going to run the Shapiro-Wilk test to ensure normality is met. I'm going to go to Analyze, Descriptive Statistics, Explore, and I'm going to select Difference as my dependent, Plots, Histogram, and Normality plots the test. Okay. And now in reviewing the test for normality in the Shapiro-Wilk results, I can see that the p-value is 0.337, which is greater than 0.05, meaning there is normal distribution, and the paired samples t-test can be used. If distribution was not normal, I could have used the Wilcoxon test, but as it is normally distributed, I will move forward with the paired samples t-test. To do this, I go to Analyze, Compare Means and Proportions, and Paired Samples t-test. Now I'm going to move my two variables over, variable 1, variable 2, and click OK. Now I can see that my mean for game 1 was 90, with a standard deviation of 13.541, and my mean for game 2 was 94.95, with a standard deviation of 14.318. So I am seeing a little bit of improvement here in the mean scores, but the question is this statistically significant? So to determine this, we're going to look down at the paired samples test results, and specifically use this bar right there to determine if this is significant. The mean difference, the difference in mean was negative 4.950 with a standard deviation of 13.137. T equals negative 1.685 with 19 degrees of freedom, and the p-value was 0.108. As this p-value is greater than 0.05, I must fail to reject the null hypothesis. But before I move forward with my findings, I want to also review the delta percentage to understand the mean average of the difference. To do this, I need to create a new variable. I go to Transform, Compute Variable, and I'm going to remove this one. I'm going to do a new one. I'm going to call this delta percent or delta percentages. And my equation for this, I'm going to use parentheticals, and I'm going to do game 2 minus game 1 divided by game 1 times 100. Okay. Now I've got my new variable here called delta percentage, and now I want to check to see what that mean percentage was. So I'm going to go to Analyze, Descriptive Statistics, Explore, and I want to make sure I have my correct new delta percentage variable selected. Everything else should be set up correctly, so I'm going to click OK. And so now I have my mean percentage, my average for the delta percentage, which is 6.6554. So now that we know this percentage, we're going to now look at our total findings and review those in page 1. I'm going to go back and open up my Word document. So, a paired samples t-test was conducted to compare students' bowling scores before and after a single 15-minute individual coaching session. Scores increased from game 1 with a mean of 90 and a standard deviation of 13.54 to game 2 with a mean of 94.95 and a standard deviation of 14.32. This is a mean change of 6.65% delta. However, this difference was not statistically significant, as t with 19 degrees of freedom equals negative 1.69, and the p-value is 0.108. Because the p-value is greater than 0.05, I failed to reject the null hypothesis. As the impact of the individual coaching session was not determined to be statistically significant, I cannot determine the effectiveness of this coaching technique from this. Now, beyond statistical significance, I do believe that there is some evidence of practically meaningful improvement. With a 6.65% change to the delta percentage, I know there was improvement after coaching. Further, even a small improvement can be meaningful, as it may move students into a different bracket or affect league outcomes. With this small sample size, there is not enough data to determine if that improvement was due to the coaching or just due to chance. However, in this scenario, there is some reason to believe that coaching may have helped and potentially could continue to help increase students' bowling scores if additional coaching sessions were repeated within the same sample. Additionally, a larger study with additional sample groups could provide additional confirmation. Thank you very much, and I appreciate you watching.